Hello, in this video, I will explain to you on how to solve this problem. Okay, let's read the problem first. In figure 27.24, the ideal batteries have EMFs of E1 is 10 volt and E2 is 0.5 of E1. And the resistance are each 4 ohm. What is the current in resistance 2 and resistance 3? Okay, maybe let's just assume the direction of the current. I will assume that this battery here gives current to the circuit, so it will goes up here. And this also goes up here. Let's name this current from battery 1 as I1. And let's name this current from battery B as I2. Okay, so this one will eventually turns right, so we will have I1 here across this R1 resistor, right? And then here I will have I2 eventually turn left, right? So we'll have this current that pass through this R2 resistance, that will be I2. And for I3, I will assume it will goes down across this R3 here. So I'll have I3 here. Good. And aside from the current, we also need to assume the polarity of the voltage. Okay. And the battery here, the long one will be the positive one and the short one will be the negative one. Okay. And this one is also the same. The long one will be the positive one and the short one will be the negative one. But for the resistor, where the current comes from is the positive side, and where the current goes to is the negative side. So see the arrow here, the plus is here and the minus is here. So again, here we have it goes to the left here, so the positive sign will be here and the negative sign will be here. Okay, the sign will be very important when doing the loop rule. Okay, now let's see I3 here. The sign will be here, the positive one, and then the negative one will be here. Good. And now let's assign the loops. Okay, let's get that loops here. And here we have the current goes up, goes to the right, and goes down. So why don't just make the loop the same as that, right? So we will have this as loop 1 here. And here we have this goes up, then it goes to the left, then goes down. So I think I will just follow that and make my loop counterclockwise for the loop 2. Good. And now what can we do here? We first apply the junction rule and then we apply the loop rule. Okay, for the junction rule, I think the only thing that we can do is applying here. Right? Let's name this node as node A. And we need to apply the Kirchhoff junction rule. Apply the junction rule at A. Okay, what does the junction rule say? It is said that the sum of the current that goes in will equal to the sum of the current that goes out, right? And what is the current that goes into node A? We will have this I1 goes into node A, right? And also this I2 goes into node A. So we will have I1 plus I2, I1 plus I2, and that will equal to this current here, which is goes to I3. So I1 plus I2 is equal to I3. Good. Now what can we do here is we apply the loop rule from loop 1 and also loop 2. Let's do the loop 1 first. Apply the loop rule at loop 1. Okay, what does loop rule say? The loop rule said that the sum of the voltage in a loop will equal to 0. However, for the voltage, we have to be very careful about the sign. Okay, let's use yellow highlighter and see where the loop goes. So here, the loop 1 here goes clockwise, and the loop enter this battery here from the negative terminal. Okay, good. So our sign will be negative. And the voltage of that battery is E1 here. So I'll have minus E1. Good. And then we move on to this R1 here. What is R1? R1 here, the loop enter from the positive terminal. So we will have plus sign. So we have plus. But remember, we need the voltage. We only have the resistance here. To get the voltage, we multiply it by the current. And the current that pass through it is I1. Okay, so I will have I1 and then multiplied by R1. Good. And now let's go down here, and the current enters from, the loop enters from the positive terminal. So our sign will be positive again. So we'll have plus here, and to get the voltage, we multiply the current and resistance. So I'll have I3 multiplied by R3. And all of that will equal to 0. Good. And now let's plug in the value. We have E1 here is 10. So I'll have minus 10. Good. And all the resistance are 4 ohm. So I will have 4I1 here, because we know the value of R1 is 4. And then plus 4I3, right? Because R3 is also 4. So I'll have 4I3. Okay. All of that will equal to 0. And we can plug that I3 is I1 plus I2. So I'll have 4I1 here. And then plus 4I3. But I3 is I1 plus I2, right? So I'll have I1 plus I2. And let's move this minus 10 to the right-hand side. So I will have 10 there. Okay, I1 only comes from this and that. So I will have 4 plus 4. That will be 8I1. And then we distribute that 4. So I will have plus 4I2. Okay, and all of that will equal to 10. Good. I think nothing that we can do from this loop. Let's save this as equation number 1. Okay, good. And now let's apply another loop rule, but this time at loop 2. Apply the loop rule at loop 2. Okay, so the sum of the voltage in a loop will equal to 0. Remember, we have to be very careful about the sign. Okay, and here we look at loop 2 here, and the loop entering this battery here from the negative terminal. So I will have minus sign, and then we will have E2 as the voltage, right? So we'll have E2. Okay, we'll have E2 here. And then let's move on to this R2 resistance. So it enters from the positive terminal here. So we will have positive sign. Okay, and the voltage is the current by resistance. So I'll have I2 multiplied by R2. Good. And now for the last component here, we enter again from the positive side of the resistor, right? It enters from here. Okay, and then I will have the positive sign. Then we will have I3 multiplied by R3 as its voltage. Okay, and then all of that will equal to 0. Good. And now what can we do? What is E2 then? E2 is 1/2 of E1. But E1 here is equal to 10, right? So I will have E2 here is 1/2 multiplied by 10. That will be 5 volt. Good. So we can plug that in. So I'll have minus 5 here. And then plus I2 is unknown. But we know R2. R2 is 4, right? So I'll have 4I2. But we also know R3. So we can plug that in. We will have 4I3. Good. And all of that will equal to 0. Maybe let's move this minus 5 here to the right-hand side. So I will have 5 here. Like this. Good. But then we will have I3 is equal to I1 plus I2. We will have 4I2 plus 4I1 plus I2. Okay, and then we will have 5 here. And if we simplify this, I will have 4I1 and then plus 8i2. Good, all of that will equal to 5, and let's save this as equation number 2. What we need to solve is this equation and this equation number 1 and number 2. Okay, let's clean up our slide and solve the equation. So this is our resulting equation. We need to solve it, right? Let's solve 1 and 2. Okay, and I think I will eliminate I2 first. I will have 1 multiplied by 2. 1 multiplied by 2. That will be, okay, I will have 16i1. Okay, and then plus 8i2. And all of that will equal to 20. And then for the equation number 2, I will leave it as is. So I will have 4i1 and then plus 8i2, and that will equal to 5. Okay, we can subtract that. We will have minus here, so we will have 12i1. That will equal to 15. So we'll have i1 here is equal to 15 divided by 12. We can divide both numerator and denominator by 3. So I'll have 5 divided by 4. And so we will have I1 here is equal to 1.25 ampere. Okay, that is I1. And what is I2? We can plug in into equation 2. Right? Plug I1 to 2. Okay, now let's do that. We will have 4i1. So 4 multiplied by 1.25 and then plus 8i2. That will equal to 5. Okay, 4 multiplied by 1.25, that will be 5, right? So we'll have 5 plus 8i2 is equal to 5. Good, and that means that 8i2 is equal to 0. Okay, therefore, we will have I2 here is equal to 0 ampere. But then remember that we have also I3, right? I1 plus I2 is equal to I3. So I1 plus I2 is equal to I3. We will have I1 plus I2 here as I3. Okay, let's make it here because I ran out of space. I1 is 1.25 and then I2 is 0 plus 0. So I will have I3 here is equal to 1.25 ampere. Okay, so we get the value of I1 here. We also have the value of I2, and then we also have the value of I3. Okay, however, we still need to answer the question. Okay, the question asking us about the current in resistance 2. Okay, let's answer that. The current in resistance 2. So I will have IR2 here, and that will equal to I2, right? I2, and we will have the direction to the left, but we have the value of 0 ampere, so the direction does not matter. So that is the current that passed through R2. Okay, and now what is the current that passed through R3? That is a different story. So I'll have IR3 here, and that will equal to I3. Okay, because we have the magnitude here, so that will be 1.25 ampere. And the direction is correct because we have the positive value here, right? So the direction is downward. Okay, and I think we have answered what is the question A and what is the question B. This is the answer. The current that passed through R2 is 0 ampere, and the current that passed through R3 is 1.5 ampere with the direction of downward. I think that's all for this problem. Thank you for watching. See you in the next video. Bye bye.